A solution of exam 20 for advanced data analysis course. I'm using the Mac. Let's go to Windows. I have already entered the network folder, digiting //ubz01fst. I open northern.accdb. Sorry for being fast, but it's the third time I'm doing it because the video continues to crash. Create query 1 that calculates how many days, how many months, and how many years is each order old. So create query design. I need only table orders. Order ID. Let's make them larger. Here. Days old colon. Well, for days, honestly, you just need to subtract order date from now. This gives you immediately the difference in days. You need to put the square brackets around order date. Unfortunately, the damned Mac with a German keyboard doesn't have the square brackets. So let's see whether Access is so kind. Yes, it is. Okay. Alternatively, you could use also datediff, but it's not really worthwhile here. Mounts old colon. Here you have two alternatives. One is divided by 30. It gives you an approximate result. The other one is using datediff with parameter m. That gives you an exact result, but sometimes it's bugged, as I told you during the lesson. Years old, same thing. You have two alternatives. I will use datediff here this time. Datediff y semicolon order date semicolon now. Okay. If the semicolon doesn't work, try the comma. Yeah, it works for me. And also the square brackets. Fine, let's see whether the result makes sense. Well, all the orders are 25 years old. Yes, they are back in the 90s, so. Okay, I saved this query. Query 1. Well done. Query 2 displays the orders which contain at least one discounted item. Ooh, difficult. Create query design. Orders. Unfortunately, the discount is in order details. Okay, order ID. So in theory, you don't even need orders because order details, order ID is also in order details. Discount larger than 0. Okay, I don't want to see the discount. Okay, the query officially is finished. If you want to do something a little more, can you see that the same number is repeated? But if you convert it to a summary query and use here where and here goodbye, you don't see the repeated numbers anymore. Okay. Query 3 displays the supplier with a count of how many products with units in stock plus units on order between 20 and 40. Okay. Create. Query design. Suppliers. Products. Okay, we need a company name. And the count. Okay, I need something to count. I will count, for example, product ID. Okay, let's make it a summary query and I will count it. Okay, then I count only those one with units in stock plus units on order between 20 and 40. So let's call it AAA units in stock plus units on order. Okay, it's not goodbye, but it's where, and the criteria is between 20 and 40. Okay, let's see whether it makes sense. Yes, makes sense. Save. Query 3. Create an update query 4, which increases unit price in table order details by a percentage corresponding to the discount. Practically we're cheating our customer. If you run it, do not accept the modifications. So create design. So order details. Well, very simple. I just need only unit price. It's an update query. So update to same thing. So unit price by 1 plus discount. Let's see. It doesn't accept the fact that I don't have square brackets. So I must find a way to produce them on the Mac. Let's see. Not here. Not here, obviously. Not here. Oh, a square bracket appeared. So it's Alt Control 8 and Alt Control 9. Okay. Well, I save it first. Now I try to run it. Okay, I don't do it. Okay, this increases the price, yes. Okay. Okay, access is done. I don't need to return, it's there, can you see? Okay, now let's start R. Have here my own R portable. Or maybe we can use the university R. Crossing the fingers, maybe. Okay, let's search the university R. 64. Packages, load package. Obviously, if you do it before the start of the exam, it's a good move. Okay, the file is companies, which was the file of the previous data, load dataset. Okay, you search for exam Coletti Paolo, companies. It was the same file of the previous exam. Okay, we don't forget the Word file, which will contain most of the stuff, which is the most important thing, by the way. Instead of oops, I'm opening Word on the Mac. No, I should open Word on Windows. It's much easier since I'm doing everything on Windows. Let's open it here. Where is Word? Microsoft Office. Not tools. So difficult to find Word. It's here. Okay. File. Save as. I go to the network folder. No. I need the backslash and look what we have to do. This dirty trick. ubz01fst. And all the rest gets deleted. Courses. Exam Coletti. Okay, let's save here. Exam. Okay. Now, let's see what do we have to do. Build and comment to appropriate graphical representation for variable sales. It's a numeric variable, a scale variable, so to appropriate graphical representation, well, box plot and histogram. I don't see any other. Let's start with the box plot, which honestly it's easier. Sales. Done. Oddio. Oh my god, what an horrible box plot. Let's take this horrible box plot, copy as bitmap. I paste it here. And let's comment it. We see that the central 50% with the lower 25% is all squeezed close to zero, while there are really a lot of extremes. Okay, I don't think we can tell something more. Oops, I'm lost. What happened? I want Windows back. Okay. Let's see the other one, the histogram. Graphs, histogram, sales. Oh, well, same thing. Copy as bitmap. It would have be nice to make a logarithmic frequency. Here, Ctrl V. Histogram shows the same thing. All the companies, almost companies, are squeezed around sales smaller than, let's say, this is 2 million, 1 million, half million. So, with several extremes up to 9 million. Okay, since it's a list of companies, probably the large one at extremes. Save. This one, we don't need it anymore. Test and comment whether the average of sales is 120,000. If you don't need to check any eventual prerequisite. Means it's a student test. So let's write it. So H0, average of sales is 120,000. H1, average of sales is not 120,000. Prerequisite sales is normally distributed, which is not, obviously. Okay, statistics means single sample t-test, sales, okay, copy, let's remove the useless things. Difference between sample average and H0 is 1900, 1815 to be precise, 814. Okay, significance is 0, therefore we reject H0, therefore average is not 120,000. Okay, save. Test and comment whether the position of sales is the same for size categories, checking any eventual prerequisite. Okay. So this is a Mann-Whitney test, no, Kruskal-Wallis. There is no prerequisite to check actually. So checking an eventual prerequisite, there is no one. H0, position of sales is the same for each size category. H1, at least for the 5th time. So now we try to recover. Let's see, we go here, Windows. At least one category has a different position of sales. Okay, Kruskal Wallis. Let's hit the Kruskal Wallis test. Statistics. What is it? Non-parametric, Kruskal Wallis. So it's sales per size. So size, sales, here it is. Copy. It's pretty short to answer. Let's remove the degrees of freedom. Okay. Significance is 0. Therefore, we reject H0 and at least one category has a different position of size. To make the professor happy, it's not required, but to make the professor happy, we draw the box plot. Box plot. Sales, plot by groups, size. Well, it's pretty evident that it's the large one, which has a different position. From the box plot on the sample, it seems to be the large category which is shifted. Okay. Open. Build variable salaries on sales equal to salaries divided by sales. Okay. So, data, manage variables in activity set, record variable, name of the new variable, salaries on sales, which is equal to salaries divided by sales. No, new variable factor, no, obviously. Why Bing? You must select a variable. Because it's the wrong one. Data, you can see what happens when you don't regularly doing exercise. Compute new variable. Okay. Salaries on sales. Salaries divided by sales. Okay. Take a look at it to see whether it really exists. Yes. Okay. What do we have to do with this variable? Test and comment whether the averages of salaries per size are equal or different, checking any eventual prerequisite. So this is evidently ANOVA, and the prerequisite is the normality. So ANOVA H0, average of salaries on sales is the same for small, medium and large. H1, at least one category of size has a different average. Prerequisite salaries on sales is normally distributed on each category. Okay, save. Statistics means one way ANOVA, size, salaries on sales. That's it. Copy. Okay. Significance is 0. We reject H0, which means that at least a category has a different average. Let's put, since we have here the averages, let's see. Well, seems all of them have a different average. So large is smaller than medium, which is smaller than size. From the sample, it seems that large smaller than medium, which is smaller than small. Okay, but we check prerequisite. Okay, whenever you check a prerequisite for something which must be split by groups, well, it's convenient to find to use one of the four methods which is automatically split by group. For example, the Shapiro-Wilk test or the QQ-plot. I will use here the Shapiro-Wilk test, which has the split by group automatically. Otherwise, for example, if you do the histogram, you have to do the histogram 3 times, splitting manually the sample. It's a mess. Statistics, non-parametric test, what is it? Summaries, test of normality. No, I have an old version of R which doesn't have the Shapiro-Wilk test, so I will have to do the old Kolmogorov-Smirnov, which is not the same, but it's a normality test. Okay. It's incredible that... because this is the one installed on the university. So if you don't have the Shapiro-Wilk, Kolmogorov, Smirnov, test by size. Also the QQ-plot will be okay, yeah. Okay, the H0 is salaries on sales is normally distributed on, let's start with large companies, H1 not normally. Okay. Let's copy it, otherwise somebody at exam will write it in an abbreviated way. Copy and paste is not. Large. Okay, it's actually 3 tests. Let's see which one makes. I have to go back to R. Retrieve the thing. Okay, this decides large. Significance is 0. We reject. It means that distribution of salaries on sales is not normal. We cannot do the test. Okay. Here, you should simply copy and paste for the medium. Okay. The conclusion is always the same, because all the significance in this case are pretty close to 0. Build and comment an appropriate numerical description of size by sector. Contingency table, two-way table, size by sector. Let's see, I try with a raw percentages. I don't have, no, I have to do the chi-square. Okay, let's see. This means that of all the large car, yes, of the large, yes, it makes sense. Okay, I copy it, I paste it. Obviously numbers are completely skewed. Is there any way to convert it into a readable table? Table, convert text to table, number of columns 1, other space, number of columns 68. No, I don't think. Paragraph, tabs, no, okay, no way. Okay, let's comment it a little bit. Among all the large companies, we can see that the majority is a telecommunication. Yes, the 18 is telecommunication. Well, look how similar the numbers are. Really, really similar. Allora, companies, which is the same for medium and small. All the raw percentages are very similar, which implies that the sector distribution of companies on the sample, at least, is not related to the size of the company. It's the same, it's the same. Each size. Okay, it's over. I close here. Oh, actually, I need only the word for the exam. But if you're sure, if there is something which I don't understand from your word, I would like to look at the other things. So, exam. So, exam.r, this one. Save output as exam.txt and save the workspace as exam.companies.rdata. Yeah, I want to replace it. Finish, shut down everything. Never goodbye R. Oh, okay. Do I have everything? Yes, the dates are correct. Okay, fine. Let's try to stop the video now.